Section 5.1, Inverse Functions. Consider if you were traveling somewhere out of the United States, pretty much anywhere in the world other than the United States, and you woke up in the morning and you heard that the temperature was going to be 32 degrees. Of course, everywhere else in the world they use the Celsius scale. We tend to use the Fahrenheit scale. You would need to have an idea of how hot is 32 degrees. What sort of clothing should I wear? So here's a table that gives some value of Celsius degrees and some value of Fahrenheit degrees. Now it turns out that the relationship between Celsius and Fahrenheit is linear. So we're going to find an equation of the line. We're going to use 2 points. I'm going to use 0, 32, and I'm going to use 100, 212. If I do that, m is 212 minus 32 over 100, and I grab my calculator. 212 minus 32 happens to be 180 over 100, which I could write as 1.8, I suppose, but I think I like the fraction. I think it's 9/5. It is. Okay, so there's our slope, and using 0, 32 is helpful because that gives us our y-intercept. So, the Fahrenheit temperature, I'm going to call it F, broke my lead, the Fahrenheit temperature is 9.5 times the Celsius temperature, here Celsius temperature is my x, plus 32. So, if you woke up in the morning and somebody told you that the Celsius temperature was going to be 32 degrees, you could figure out the Fahrenheit temperature. F is 9/5 times 32 plus 32, which is 89.6. So it would be a pretty hot day. Want to dress appropriately for the weather. Now, what this does, this function assumes that the Celsius temperature is our inputs, these are our x values, and the Fahrenheit temperature is our y values. Somebody visiting the United States from a different country would want these to be reversed. They would wake up in the morning and they would see that the temperature is going to be 50 degrees. So they would be given the Fahrenheit temperature, F is 50 degrees, and they would want to know what's the Celsius temperature going to be, because that's the units they're comfortable in dealing with. Now, using this formula, we could, of course, figure it out. I mean, I could plug in 50 and solve. So I subtract 32 on both sides. 18 is 9/5 C. Divide, C is 18 divided by 9/5, 10 degrees Celsius. But it would be a lot more helpful for this theoretical person if the F and the C interchanged positions. It would be a lot more helpful if we had C equals something with F in it. And that's called the inverse function. So let f of x be a function. G of x is called the inverse function of f of x when f of a equals b implies that g of b equals a. So notice what the inverse does. For f, our input is a, our output is b. Our x is a, our y is b. For g, it switches. The input is now b, the output is now a. So the x value becomes b, the y value becomes a. Alright, so I'm going to take this function that we had, f equals 9/5 c plus 32, and I'm going to find its inverse. And what you do to find the inverse is you solve for the other letter. So here we have f all by itself. To find the inverse, I want to get c all by itself. So to get c all by itself, I would subtract 32 on both sides. So f minus 32 is 9/5 c. And then to get the c all by itself, I would multiply both sides by 5/9. So c equals 5/9 times f minus 32. And this would be called the inverse function. And quite often the symbol we would use, if f is our original function, then this symbol, f inverse, is the inverse. Alright, so that's not a great symbol because it looks an awful lot like an exponent, but it's really not an exponent, okay? This is just a symbol for inverse. So you just have to get used to that. Alright, so look at what this function would do now. This function would have inputs that are Fahrenheit values and give you outputs which are Celsius values. So if my Fahrenheit value were, say, I don't know, let's make one up. I'll write this down on a new page. C equals 5/9 f minus 32. So now let's say somebody woke up in the morning and they saw the Fahrenheit temperature was going to be 72 degrees. What would the Celsius temperature be? All they would have to do is plug into this formula. It wouldn't really be anything to solve. So that's 5/9 times 40. Grab my calculator. 22.2 degrees Celsius. Okay, so your first set of homework problems are going to look like this. I'm going to give you a function. F of x equals 1/2 x minus 3. And the directions are going to be find the inverse function. Well, typically what we do is we write y equals 1/2 x minus 3. Just because it's easier to write y than it is to write f of x. The big thing the inverse function is going to do is it's going to interchange inputs with outputs. So I'm going to interchange the inputs and the outputs. So I replace all the x's with y's and all the y's with x's. And then what I need to do is take this equation and get y all by itself. To do that I add 3. And then to get rid of the 1/2, I could divide by 1/2, but even easier is to multiply by 2. So there would be my answer. My answer would be f inverse of x is 2 times x plus 3, which of course you could write as 2x plus 6. Alright, so here's your first homework problem. F of x is 2/3 x plus 4. Find f inverse of x. I'm going to do one more of those. Let's say I get g of x is, let's see if I can find an interesting one in the book here. Do they have any good ones? How about 2x minus 7 over 4? Alright, again, if I wanted to find the inverse, here's the symbol I would use for it. I would have y equals 2x minus 7 over 4. And then I would switch my x and my y. And then I got to get the y all by itself. To get the y all by itself, I think I would start by multiplying by 4. And then I could add 7. And finally divide by 2. So my final answer would be g inverse of x is 4x plus 7 over 2. Alright, so here's homework number 2 for you. G of x is 6x minus 2 over 5. Find g inverse of x.